Assalamualaikum and hi class. In this video, I will explain about another mechanism of electrophilic addition in alkene, which involve the hydration reaction. In this mechanism, we have three steps involved. The first step is formation of carbocation ion. The second one is formation of protonated alcohol, and the third one is elimination of H+. Alright, so let's look at this example. I use this alkene 2-methyl 2-butene react with acidified of water. This is the reagent of hydration reaction of alkene. So we will get an alcohol. So let's look at the first step in this mechanism named formation of carbocation ion. So first, you copy back the structure of the alkene involved and you expand the bond of a C-C double bond because we are going to show the movement of electrons in the mechanism. So the first step, this alkene, it will react with H3O+. H3O+ here is from our acid H2SO4. This is as the catalyst in the reaction. So what happened here is the CC double bond, which is electron rich, will attack the hydrogen of the H3O+. So the arrow must be from the CC double bond. It will attack the H here, which makes the OH bond break and 2 electrons will go to the O. So what will we get in this first step is first, the carbocation ion. H here will be attached to the carbon with more hydrogen. So now let's look at our carbon. These two carbons, this carbon has more hydrogens. That's why the hydrogen from H3O+ that break here will attach to this carbon, and this carbon will become the carbocation ion. Class, same as previous mechanism that we discussed, if the formation of carbocation ion, we have to identify types of carbocation ion. In this case, this carbocation ion is tertiary carbocation ion, while their neighboring carbon is primary and secondary. So this carbocation ion is already more stable carbocation ion that can be formed. So no rearrangement will occur in this mechanism. Alright, and the other product that will be formed here is H2O, because from H3O+, OH bond already break. So left here is H2O. So this is our first step. Next, we will go to the second step. It is formation of protonated alcohol. So the carbocation ion formed from our first step will involve again in the second step. So the water, the reagent of the hydration of alkene, the water here will take part in the second step. What happened here is, look at the lone pair on the oxygen. The arrow is from the lone pair to the carbocation ion. So this oxygen will attack this carbocation ion. Always remember that arrow will always from electron rich side to electron poor side. So here O has a lone pair, so it will go to the carbocation ion, which is electron deficient. So what we will get here is we will have protonated alcohol. Protonated alcohol is OH here. This OH is alcohol with one proton, one extra proton. So we call this as protonated alcohol. So this is our second step in this mechanism. The third step is elimination of H+. So I will copy back the protonated alcohol form from the second step. So what will happen here is H2O will involve again in this step, and this lone pair will attack the H of protonated alcohol, which make the OH bond here break and 2 electron will go to the oxygen. So what we will get is we will have our alcohol product and also H3O+, because H2O already get back its hydrogen. So remember, this is from our catalyst H2SO4. Remember, catalyst, its characteristic is it will remain after the reaction complete. So H3O+ will gain back in the reaction as sulfuric acid. That's all for the mechanism of hydration of alcohol.